So we're going to draw the wiring layout for this diagram, for this circuit, and we saw that the NOT gate was, what did we just say it was, 7404?
Yes.
7404, and we need the AND, which we think is 7408. So to check chips available in the lab, (7408), yep, and that's the 2-input AND. So then I made, and I did not have time to post it, this nice paper that has the just has the, I put the 7404 on top and what's the same for the AND and the NAND at the bottom, and just make it easy to draw. Would anybody like me to print out this so you don't have to draw your own? I just find it easy, but you don't need it. Okay, so I will grab this. And I will say, since my AND gate has, it's a quad input, means it has 4, the chip itself has 4 gates on it, that they will all be on the same chip, and my NOT has 6, so I certainly have enough for that. So this will be chip number 1 and chip number 2. So I'll label these 1 and this one 2. Now if I needed 2 AND gates, I would just have a third one on there. And then for my NOT gates, I know that the input is A and the output is Y, and so 1A, 1Y, 2A, 2Y, 3A, 3Y, and then we can look at I'm trying to avoid going to look up the another data sheet on the website. There we go. So I'm trying to remind myself. Okay, so we put in parentheses the pin number, and we put the 1A, 1B, we just write that out. So So for this first NOT gate, that would be 1A, and the output would be 1Y. And for my second NOT gate, it would be 2A, and the output would be, did it just disappear? Okay. Okay, and the output would be 2Y. And then I'll look at the pin numbers. So 1A is on 1 and 1Y is on 2. And 2A is on 3 and 2Y is on 4. And then for my ANDs, the inputs are A and B and my outputs are Y. So I'll have 1A and 1B and 1Y, and 2A and 2B and 2Y, and 3A and 3B and 3Y. And 1A, and I don't have to use 1, 2, 3. I could do 1 and 3 and 4. I don't have to use them. I just usually do to keep them in order. So 1A and 1B are 1 and 2, and 1Y is 3. And 2A is 4, and 2B is 5, and 2Y is 6, and 3A is 9, and 3B is 10, and 3Y is 8. So that's the first step, is you label that. And then the second step, tell me when y'all are ready. Second step is to go here, and my inputs were A, B, and C. And you'll draw a wire for ground. And pin 7 of each of these will go to ground. And you'll draw a wire for VCC. And each of those will go there. And then A went to pin 1 of chip 2. This was chip 2, and this was chip 1. So A went to pin 1 of chip 2, and B went to 2 and 4, went 2 and 4 of chip 1. And C went to 5 of chip 1. And then we had from chip 1 we had pins 3, pin 3 goes to pin 9, and pin 6 goes to pin 3 of the other chip, looks like I missed pin 2. What goes to pin 2? Pin 2 goes to pin 1. So pin 2 of the knot goes to pin 1 here. And pin 4 of the knot goes to pin 10 of the and. And pin 8 of the and is my output, F. And it looks like I got them all. Okay, so let's talk now about the ones that y'all need to do. So you'll do the same idea, but the first one, you have to show how to connect the pins of a 74X04 hex inverter chip to implement the circuit below. And I believe what you are doing with this is just measuring whether, just testing the circuit at that point. Can anyone remember what you're actually doing with this? Has anyone read the lab? No.
It's more logic analyzer.
Okay. Yep. Okay, so what you're going to be doing is the Y1, Y2, and Y3 is where you're going to be putting the logic analyzer, and you'll be watching the signal on the computer screen. And so you'll see the delay as it goes through. You'll see it cascading. You won't see it in real time. You'll see it in the signal. In real time, unless your eyes are really fast, you won't actually see, but you can see on the signal how it takes time to go through the gates, and so it's not automatic. And so what you'll have is this is the knot. Yeah. So we want to measure the output. So I'm not going to draw everything because I said in my email that this would be a chance for y'all to work on it. But we want to measure the output after it's going through 1, 2, 3, 4 NOT gates. So you'll have your input, and your input will be going into gate 1. And then your output, now remember on your circuit board, you'll have, so here's pin 1, here's pin 2. You have multiple holes right here. So you're going to have one of those is going to go to, it might be too hard. You might not want to use the one right next to it. We have to use 4 of them. 1, 3, 6, and 5. Yeah, it's just so you don't have it so crowded. You might want to have it go to 3 instead. But then, so on your circuit board, you'll have this one, pin 2, 3, 4, 5. You'll have a wire going from here to here. And you'll also have a wire here going to what's going to be your analyzer, your circuit analyzer. Trying to remember what it looks like. It has the little, it has like these little hooks on it. Like, so the circuit analyzer, it's got these wires, right? And then at the end of the wires, it's got,
Okay.
and then how do you attach it?
They kind of just slot into the hooks on the logic
It's
analyzer.
like a plastic piece and slide the wire onto the plastic and it's...
So on the logic analyzer, you've got a little bundle of wires and a connector to connect to the square logic analyzer. The black wires are ground, and if you look on the bottom of this thing, it kind of sort of shows which place the ground should be, so it shows you what order it goes in. And then, oh right, you have these things. Oh, I hated these. I never can make them work right. And then you shove this in here somehow. Is that right?
Yeah,
And
there's
then-
cycles on the side.
Yeah. And then you have these little grabbers.
Mhm.
Okay. So My guess is that you're going to put just a plain wire into one of the holes on the circuit board and attach this onto the wire, one of the ones that is like where I have that kind of greenish line right there. And then you'll attach the logic analyzer to that. But you don't need that for the pre-lab. All you need for the pre-lab is to show that this right there is Y1. Okay, so I'm gonna stop with this one and we'll do the NAND gate, and then y'all will have a little bit of time to get yours set up and see if you have it right, and then ask me questions. So for the NAND gate, you would have, okay, so it's just not going to let me select that one NAND gate. Okay. So how many chips do you need to do the NAND gate?
One,
Yeah, just one. How many did you need for the NOT gate?
one.
Yeah, just one. So I didn't actually draw the circuit for the NOT gate. I didn't label them, but you would label them like we did on the first one. So for the NAND gate, you would have one A, one B, one Y, and it doesn't have to be like this. But this, you can have. I'm making this one 1. You could have made that one 2. 2B. Sorry, 2A. Could have been 2B. 2B. 2Y. And then 3A, 3B, 3Y, and so forth. And then you would put the pin numbers. So that would be 1, 2, and 3. And you put the pin numbers for each of those. And then you would do your circuit diagram. Oops, sorry, I got my... And I had X going to pin 1, and I had Y going to 2A and 2B, and I had Z. I didn't have what Z was going to, so I had Z going to 3A. was pin 9. And so that's what you would do. So why don't y'all spend a few minutes like going ahead and drawing your diagrams for your pre-lab so you can get that out of the way, and then if you have any questions while you're drawing it, I'll be right here. And then I'm going to do some Verilog if we have some time left over. So I'm just going to stop this and upload it. Do y'all have any questions before I stop?